In this video, I will be covering problems from trigonometry. So I had a lot of requests for this topic. So the first problem is the period of this sine by cos plus sine by cos plus this is what? So we know that period of sine x is period of sine x is 2 pi, right? And what does that mean? It means if you add 2 pi to x, then you get sine x itself, right? So after a cycle of 2 pi, all the values are repeated. As you can see in the graph, if you draw a curve of sine x, this is 0, this is pi, this is 2 pi. After 2 pi, the cycle repeats. So that is the period. This is 4 pi. Cycle repeats again. So this is that. And so if period of sine x is 2 pi, then period of sine 2x is 2 pi by 2. Sine 3x is 2 pi by 3. Sine 4x is 2 pi by 4. Similarly is for cos x. Period of cos x is also 2 pi. Cos 2x would be what? 2 pi by 2. Cos 3x would be what? 2 pi by 3. Cos 4x would be 2 pi by 4. Right? So in this problem we have sin x, cos 3x. So period of sin x is 2 pi. Cos 3x is 2 pi by 3. Sin 3x will be also 2 pi by 3. Cos 81x would be 2 pi by 81. So all of these options are there, 2 pi by 3, pi by 81, etc. etc. But if I add 2 pi by 81 to sin x, do I get sin x? No, it's not equal to, as you can see from the graph, it's not equal to that. That is, if this is 0, if I add 2 pi by 81, it is somewhere around here. So sin 0 is 0 and 2 pi by 81 is a non-zero value. So this is not the period for this. So this option is gone. Similarly, 2 pi by 3 is also gone. 2 pi by 3 is what? 120 degrees. This is sin 0, 120 degree is like somewhere here. So sin 0 is 0 and sin 120 is somewhere here. So this is also not the period. So the obvious options are pi and 2 pi. If I add 2 pi, sin pi plus 2x is sin x, obviously. Cos 3x plus 6 pi would become cos 3x. So it satisfies. But here's the trick. Pi is also working in this case. If I do sin x plus pi divided by cos 3 into x plus pi. Right, let us try to open the brackets. Sin pi plus theta is minus sin theta. This is cos 3x plus 3 pi. So 2 pi is the period for cosine. So if I write it as 2 pi plus x, cos 2 pi plus theta is cos theta. So cos pi plus x. Sorry, this was 3x. So cos pi plus 3x. So this is equals to minus sin x by cos pi plus 3x. Now cos pi plus theta is also minus cos theta. So this is equal to sin x by cos 3x. So pi is the period. If you try to do the same in this one, this will also become minus sin x and this will become minus cos x, minus minus cancels. So you don't need 2 pi. This value is the same if you add pi to x for this as well, for this as well. Hence the period is pi and not 2 pi. So this was the tricky part over here. You know, all the periods for these are, this is 2 pi, this is 2 pi by 3, 2 pi by 3, 2 pi by 9. First you take the LCM, LCM will come up to 2 pi. So 2 pi should have been the period, but since these two are divided with each other, or even if they were multiplied, even if it was sin x cos 3x, then also period would have been pi. But if the problem was like this, sin x plus cos 3x plus cos 9x plus sin 3x plus dot 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 till here plus cos 81x. In this case, the period would have been 2 pi, no doubts. But since these two are divided, or even if they were multiplied, the period is now pi because minus signs are getting cancelled. Next problem. If alpha is equals to, I did a mistake while copying. This is sine cube x by cos square x and beta is equals to cos cube x by sine square x, and sine x plus cos x is equals to k, then alpha sine x plus beta cos x plus 3 is equals to what? So let's put the value of alpha. Alpha sine x plus alpha is sine cube x by cos x into sine x plus cos cube x by square x sine square x, so it's cos square x into cos x plus 3. Sine 3 into sine is sine raised to the power 4 by cos square x plus cos 3 into cos is cos raised to the power 4 by sine square x plus 3. Now I want to take an LCM over here, so I will get sine square x cos square x sine raised to the power 6x plus cos raised to the power 6x plus 3. Now I want to write it in this way: sine square x cube plus cos square x cube by sine square x cos square x. Why do I write it as sine square cube and not sine cube square? Because we know that sine square plus cos square equals to 1, and I want to make use of that. That is why I have done it. We know that a cube plus b cube is equals to a plus b whole cube minus 3ab into a plus b. So this is sine square x plus cos square x whole cube minus 3 sine square x cos square x into sine square x plus cos square x divided by sine square x cos square x plus 3. Now what is this? Sine square plus cos square is 1, so 1 cube minus 3 sine square x cos square x. This is also 1, right? Sine square plus cos square plus 3. Now I want to take LCM again. So this is like 1 minus 3 sine square x cos square x. 3 multiplied with this sine square x cos square x by sine square x cos square x. This whole thing gets cancelled, right? So I'm only left with sine square x cos square x. In the problem, value of this thing, alpha sine x plus beta cos x plus 3 is asked to me in terms of k. There is no sine or cos in here. And what is k? K is given to me as equal to sine x plus cos x. Sine x plus cos x equals to k. So from here I have to find out the value of sine square x cos square x in terms of k. How do I do that? Just square it. If I square it, I will get a square plus b square plus 2ab. This is k square. What is this? This is 1. So 2 sine x cos x is equals to k square minus 1, or sin x cos x is equals to k square minus 1 by 2. So this thing is what now? Sin x cos x whole square, right? And sin x cos x is k square minus 1 by 2. So whole square. 2 will go up. 2 square is 4. 4 by k square minus 1 whole square. 4 by k square minus 1. So this is the correct option. Okay, next problem. If a plus b plus c is 60, and then this whole thing is equal to what? So I would say this is a very easy problem. Just have to use this formula: cos x plus cos y is equals to 2 cos x plus y by 2 into cos x minus y by 2. You can also write cos y minus x by 2, because cos of theta is equals to cos of minus x is equals to cos x. It's an even function, so you can write it both ways. So cos 30 minus a plus cos 30 minus b. Let us first deal with this expression. I will use this formula. So 2 cos 30 minus a plus 30 minus b by 2 into cos of 30 minus a minus 30 plus b by 2. 30 and 30 are cancelled. So 2 cos 60 minus a minus b by 2 into cos of a minus b by 2 or b minus a by 2, one and the same thing. As I just said, cos of minus x equals to cos of x. So I can also write it as a minus b by 2. Now a plus b plus c is given to me as equal to 60. So 60 minus a minus b would be what? C. So this is 2 cos c by 2 and cos of, let us write it as b by 2 minus a by 2. Now this is another formula, cos of x minus y is cos x cos y plus sin x sin y. These are all very basic trigonometry formulas, everybody should be knowing them. So this becomes equals to what? 2 cos c by 2 cos b by 2 cos a by 2 plus sin b by 2 sin a by 2. I will write it as this: 2 cos a by 2 cos b by 2 cos c by 2 plus 2 sin a by 2 sin b by 2 cos c by 2. So this is starting to look like the answer that is required in the form of a by 2 b by 2 c by 2. Okay, so now let us deal with this. Cos 30 minus c plus sine of a plus b plus c. Sin a plus b plus c is given equal to me as 60 degrees, right? So this is sine 60, and sine 60 is equals to cos 30, right? This is equals to root 3 by 2. So I'm going to substitute this with cos 30. Why do I do that? Because I want to reuse this formula. I want to reuse this formula, cos of x plus cos of y. So this is what? Cos of 30 minus c, sorry, 2 cos 30 minus c plus 30 by 2 into cos of 30 minus c minus 30 by 2. 30 and 30 are cancelled. 2 cos 60 minus c by 2 into cos of minus c by 2. Now a plus b plus c again is equals to 60. So 60 minus c is what? A plus b. This is a plus b. 2 cos a plus b by 2. And cos of minus x equals to cos x. So this is cos c by 2. Now what do I do here? 2 cos c by 2. I will write it as cos of a by 2 plus b by 2, because I want to use this formula now. This one. So this is cos of x minus y. So cos of x plus y is equals to cos x cos y minus sin x sin y. This is also a basic formula everybody should be knowing. So this is equals to 2 cos c by 2 into cos a by 2 cos b by 2 minus sin a by 2 sin b by 2 is equals to 2 cos a by 2 cos b by 2 cos c by 2 minus 2 sin a by 2 sin b by 2 cos c by 2. Now I have to add these two parts. This is 2 cos a by 2 cos b by 2 cos c by 2 plus 2 sin a by 2 sin b by 2 cos c by 2. Over here this is minus, the rest is same. So 2 plus 2 would be what? 4. So my correct option would be for this. Right? So next problem. Okay, I would say this question was a bit tricky, or better than the other problems. So I am given mod of sin x minus cos square x. I have been given 3 minus 3 sin x plus sin square x, and I am given 4 times sine mod of sine x minus 1. So this is more of I would say differential calculus maxima minima kind of question rather than trigonometry. Trigonometry is very less. So we know that sine x is always lying between minus 1 and plus 1 included. Sine x is never greater than 1. So sine x minus 1 is always less than 0, or at max it can be equal to 0 only when sine x equal to 1, right? So you can safely write sine x minus 1 mod is equals to minus of sine x minus 1, because this is always less than or equal to 0 at some points. So this is equals to 1 minus sine x. So this value, this becomes what? 4 into 1 minus sine x. We have removed that nasty mod sign from here. Now I want to remove it from here as well. 3 minus 3 sine x plus sine square x. Okay. Can we do square completion? Yes, we can. Sine x minus 3 by 2 whole square. Sine square x minus 3 sine x plus 9 by 4. So 3 minus 9 by 4. So this is equals to mod of sine x minus 3 by 2 whole square plus 3 by 4. So this is a positive number, this is a positive number because this is a squared. So the sum is also a positive number. So mod of that number will stay that number, right? So mod of this is equals to this. So my question is now reduced to mod of sine x minus cos square x is greater than equal to 3 minus 3 sine x plus sine square x plus 4 into 1 minus sine x. So 4 minus 4 sine x. Cos square can be written as 1 minus sine square x. So this is sine square x minus 7 sine x plus 4 plus 3 is 7. This is what? Sine square x plus sine x minus 1 greater than equal to sine square x minus 7 sine x plus 7. Okay, now this is what the question has reduced to. Now you have to see whether this thing is greater than equal to this. You can see that there is a 7 over here, or 7 is also here as well anyway. So first things first, can we reduce the mod sign from here? Let us look at sine square x plus sine x minus 1. I can write it as sine x plus half whole square minus 1 minus half square, right? So this is equals to sine x plus half whole square minus 5 by 4. So this is positive, but this is negative. So I cannot just remove this mod sign. It's not possible because this is not always a positive number, right? But is it always a negative number? If it is always a negative number, I can write it as minus of sine square x plus sine x minus 1, right? I can do that. But that is also not possible, because if sine x equals to say 1, this is 1 plus 1 is 2, 2 minus 1 is 1. So it can be 1. If sine x is 0, then it is 0 plus 0 minus 1. So then in that case it's negative. So it's both negative and positive. So simply removal of mod sign is not possible in this equation. So let us just write it as this way, what I have done right now. Sine x plus half whole square minus 5 by 4 is greater than equal to sine square x minus sine x plus 7. Now we will do some thinking over here. Some thinking is required. What is the maximum value this whole expression can take? When sine x equals to 1, this becomes 1 plus 1 by 2 square, or it becomes 9 by 4. So this becomes 9 by 4 minus 5 by 4, 1. The maximum value this whole expression can take is 1. Right? If sine is 0, then this becomes 1 by 4 minus 5 by 4, so minus 1. If sine is half, then it becomes 1 minus 5 by 4 minus 1 by 4. Maximum value happens only when sin x equals to 1, and this is the maximum value 1. Now let us look at this thing. What is the maximum value this thing can have, or what is the minimum value this thing can have? I can also write it as squares over here as well, right? 7 minus 7 square by 2 square. This becomes sin x minus 7 by 2 whole square, 28 minus 49, so minus 21 by 4. So minimum value of this expression is when this is minimum, right? This value is constant, minus 21 by 4. Minimum value will happen when this is minimum. When will this be minimum? This is a positive number, by the way. So minimum will happen when sin x is equals to 1, and maximum will happen when sin x equals to minus 1. Sin always varies between 1 and minus 1. So at minus 1 this becomes minus 9 by 2 square, or 81 by 4. 81 by 4 minus 21 by 4 is what? 60 by 4, which is 15. 15. When sin is minus 1, this becomes 7 and 7, 14, and 1, 15. So when sin x equals to 1, this becomes 1 minus 7 plus 7, or 1. This expression can have a minimum value of 1. This expression can have a maximum value of 1, and 1 is greater than or equal to 1. So this equation satisfies only in this case when sin x equal to 1. This is the solution. Only for this little tiny expression we have been busting ourselves, trying to do this or that. Only for this very simple result. Sin x equals to 1 is the only solution for this big equation. And from the graph of sin x, we know that when sin x equals to 1, when you draw the graph, 0, this is pi, 2 pi, 3 pi, 4 pi. At this value, pi by 2, and at this value, 5 pi by 2. Pi by 2, 5 pi by 2, 9 pi by 2, or you can write it as 4n plus 1 into pi by 2. N is an integer. So this one. This is the correct solution for this question. This was a very good tricky problem, I would say. Other problems are like very straightforward. This one was a bit tricky. Okay, so in this question, we have to go step by step. Otherwise, you will not be able to solve it. You will get confused if you try to do too much at once. So we have to find out the number of real roots of the equation which are greater than or equal to 1. So it is given that sine of 2 cosine inverse of cot of 2 tangent inverse of x is equal to 0. We have to solve for this equation. Okay, this is sine, and so we need to know for what all angles sine is 0. We know that from the graph of sine x, this is 0, pi, 2 pi, 3 pi, and if we go further, 4 pi. All these values, sine is 0. So I have reduced the equation by one step. Tangent inverse of x is equals to 0, pi, 2 pi, 3 pi, 4 pi, or you can write it as n pi, where n belongs to z. Now this is 2, let us divide this by 2 over here. This is equals to n pi by 2, or 0, pi by 2, pi, 3 pi by 2, 2 pi. Just an example. Now take cos on both sides. Now we need to find out these values. Okay, we know the graph of cosine, just like I drew for sine. This is 0. On 0 it is 1. On pi by 2 it is 0. 3 pi by 2 it is minus 1. 2 pi, sorry, 5, what should I say? This is 2 pi, and on 2 pi this is 1. So 2 pi minus pi by 2, 3 pi by 2, it is 0 again. So as we can see, the values that this will take at 0, pi by 2, pi, 3 pi by 2, 2 pi are either it is 1, or it is minus 1, or it is 0. At all these 0, pi by 2, 3 pi by 2, pi, 2 pi, you can see at 2 pi it is 1, or 0 it is 1, and at these values this is 0, and at this value it is minus 1. So that's it. These are the values of cot of 2 tan inverse x. Now I want to convert this to tangent. Okay, so tan would be what? We know that tangent is reciprocal of cot, so 1 by 1 is 1, 1 divided by minus 1 is minus 1. So this can be either be infinity or minus infinity, right? 1 divided by 0 can be either for this or this. Now 2 tan inverse of x is equals to tan inverse of 2x by 1 minus x square. So tangent of 2 tan inverse of x is equals to tangent inverse of 2x by 1 minus x square. So sometimes I call it tan, sometimes I call it tangent, so it's one and the same thing. So 2x by 1 minus x square. The given values for 2x by 1 minus x square is like either plus minus infinity, or it is 1, or it is minus 1. Let us consider this first. This can only happen when the when the denominator is 0, that is this is 0. This happens when x is 1 or minus 1, right? We put x equals to 1, this becomes 0. If we put x equals to minus 1, again this denominator becomes 0. Now let us look at this. 2x equals to 1 minus x square, or x square plus 2x minus 1 is equals to 0. X equals to minus b plus minus square root of b square minus 4ac by 2a is equals to minus 2 plus minus 2 root 2 by 2 is equals to minus 1 plus minus root 2. Now let us consider this case. 2x by 1 minus x square equals to minus 1. So 2x equals to minus 1 plus x square, or x square minus 2x minus 1 is equal to 0. X equals to this plus minus square root of b square 4 plus 4 by 2. 2 plus minus 2 root 2 by 2 is equals to 1 plus minus root 2. So let us collect all the values of x that we have found out till now. X equals to minus 1 comma 1, from here root 2 minus 1, and minus root 2 minus 1, and root 2 plus 1, and 1 minus root 2. I think I have collected all the values correctly. Please let me know if there's a mistake. Now let us see what the problem states. It states all the values that are greater than or equal to 1. This is greater than equal to 1. No. This is greater than equal to 1. Yes, this is equal to 1. What is this? We know square root of 2 is 1.41 approximately. So this value is approximately equal to 0.41. So not greater than equal to 1. So this is gone. This is completely negative. So this is gone. This is 1.4 plus 1, so greater than equal to 1, yes. And this 1 minus 1.4 approximately equal to minus 0.4, so this is also not there. So the given solution is only 1 and root 2 plus 1, 2 roots. So this option is correct. Okay, next problem. If secant hyperbolic inverse of half minus cosecant hyperbolic inverse of 3 by 4 is equals to log of k, then k is equals to what is what we have to find out. So this is very straightforward problem. All you need to know is the formula for secant hyperbolic inverse of x. I've seen that in this exam, they always ask a question on this: tangent hyperbolic inverse, secant, sine, cosecant, whatever. If you know all these formulas, then this problem is for sure easy to solve. So before you go and give this exam, please try to see the formulas for these hyperbolic inverse and hyperbolic functions. Otherwise, you will not be able to solve this problem. And they always ask like either one or two, one in trigonometry and one in functions. At least one is always there. So these are the formulas for secant and cosecant. So secant hyperbolic inverse half would be what? Log of 1 plus square root of 1 minus 1 by 4 by half, right? So this is equals to log of 1 plus root 3 by 2 divided by half, which is equals to log of 2 plus root 3. Similarly, cosecant hyperbolic inverse, what is given? 3 by 4 is equals to log of 1 plus square root of 1 plus 3 by 4 whole square divided by 3 by 4. This is just a plus minus problem. It's very straightforward. All you need is to remember the formula. 1 plus 9 by 16 is 25 by 16. Square root of 25 is 5. Square root of 16 is 4. 1 plus 5 by 4 is 9 by 4 divided by 3 by 4. So 9 by 3. So it is log 3. So this minus this is log k. So log of 2 plus root 3. It was 2 plus root 3, right? Yeah, 2 plus root 3 minus log of 3 is equals to log of k. So what is k? K is equals to 2 plus root 3 by 3. In the solution, the given options that we have, we do not have any square root of 3 anywhere. But we do have k square. So I need to get rid of this square root of 3. K square would be what? A square plus b square plus 2ab, so 2 square plus root 3 square plus 2 into root 3. In the exam, you don't have to write all these formulas, just straight away write the square, right? Otherwise, you waste too much time. Take 9 here, so 9k square is equals to 2 square is 4, root 3 square is 3, 2 times 2 is 4 root 3. 9k square is 7 plus 4 root 3. Again, in the options, there is no root 3. I have to get rid of this root 3. Root 3 was what? Root 3. 2 plus root 3 is equals to 3k. Take 3 here. So root 3 is 3k minus 2. I'll put this value over here. And I get rid of the irrational number, which is square root of 3. 7 plus 4 into 3k minus 2. 9k square is 7 plus 12k minus 8, or 9k square minus 12k plus 1 equals to 0. Nine k square minus, okay, this one. Next problem. The perimeter of a triangle ABC is 6 times the arithmetic mean of the sine of these angles. We know that in a triangle ABC, there are 3 angles. So arithmetic mean would be what of the sines would be what? You have sine A, you have sine B, and you have sine C. You add all the numbers and then divide by the total of these numbers. There are 3 total numbers. So this is the arithmetic mean. And this is equals to perimeter of triangle ABC is equals to 6 times of this thing. Perimeter, we know that perimeter is what? A plus B plus C is 2 sine A plus sine B plus sine C. We know that in a triangle, sine A by A equals to sine B by B is equals to sine C by C is equals to constant K. So I will just use this and write it as sine A equals to AK, sine B is equals to BK, sine C equals to CK. K is the constant we don't know. So A plus B plus C. Let us write it as small a, small b, small c, otherwise there will be confusion. These all are lengths of the sides, which is the same as this one. Is equals to 2 into AK plus BK plus CK. This is also A. A plus B plus C is equals to, I take K out, A plus B plus C. So K is equals to half. K is equals to half, and also we are given the side BC is of unit length. BC is this, and it is denoted by small a. So small a is equals to 1. Unit length is 1. So sine A by A is equals to, given to me as half. So sine A is given to me as 1. So this is half. So sine A is equals to half. You know that sine is half for 30 degrees or pi by 6. So this is the correct answer. So in this question number 8, we are given in a triangle ABC with usual notation. If r equals to this, then 2r is this. We know the formula first, right? R is delta by S, R1 is delta by S minus A, R2 is delta by S minus B, R3 is delta by S minus C, and we know that capital R is A, B, C by 4 delta. So let us just put in the formulas. So this is delta by S minus A minus delta by S minus B minus delta by S minus C. Cancel the deltas. So 1 by S is 1 by S minus A minus 1 by S minus B minus 1 by S minus C, S minus A, S minus B, S minus C. I have taken the LCM, so this minus S minus A into S minus C minus S minus A into S minus B. This is equals to 1 by S. Now over here, I will take S minus A common from these two. This is S minus C plus S minus B. S minus A, S minus B, S minus C is equals to 1 by S. This is equals to S minus B into S minus C minus S minus A. 2S minus B minus C. We know that 2S equals to A plus B plus C. So 2S minus B minus C is equals to A. S minus A, S minus B, S minus C is 1 by S. So cross multiply S minus A, S minus B, S minus C is equals to S into S minus B into S minus C minus AS into S minus A. Now I will take this over here. S minus B and S minus C will be common. From here I will get S minus A. From here I will get minus S. This is equals to minus AS into S minus A. S and S are cancelled, so S minus B into S minus C into minus A, minus here is minus AS into S minus A, minus minus cancelled, A cancelled, S minus B into S minus C is equals to S into S minus A. So this is, I would say this is not an easy problem. Now open the brackets. S square minus B plus CS plus BC is equals to S square minus AS. So this. So BC minus B plus CS is equals to minus AS. I would say now is the correct time to put in this formula in this question. Okay. So BC minus B plus C into A plus B plus C by 2. I will bring this over here as well, plus A into A plus B plus C by 2 is equals to 0. Now, so 2BC minus AB minus B square minus BC minus AC minus BC minus C square plus A square plus AB plus AC is equals to 0. AC and AC are cancelled, AB and AB are cancelled, 2BC cancelled with this. So A square minus B square minus C square is equals to 0, or A square is equals to B square plus C square. So if this is the triangle, this is a right angle triangle property, right? Hypotenuse. So this is A, then this must be A, B, C, this is B, this is C, this is right angle triangle. So area of this triangle is what? Half into base into height, half into B into C, right? And we know that R is equals to A, B, C by 4 delta. A, B, C, 4 delta half into B, C, right? BC and BC are cancelled, so this R is equals to A by 2. This is the solution. In the question, what is being asked? 2R. So 2R is equals to A. I would say this is not an easy problem because you have to do so many calculations and so many plus minus here and there. Chances of making a mistake are too high in this problem. So if you are going to attempt this problem, you have to be very careful. So this is the last problem, question number 9, again on in radius, circumradius, etc., etc. So let us look at this one first. Tan A by 2, which is also equal to S R by S minus A, is equal to which of these expressions? We know that R is equals to delta by S, right? So R by S minus A is delta by S into S minus A. If I multiply numerator and denominator with S minus B into S minus C, what do I get here? This is delta square, right? Because we know that delta is equal to square root of S into S minus A into S minus B to S minus C. So if we remove the square root, so this is delta square. Remove the delta, you get S minus B to S minus C by delta is equals to R by S minus A. So option A is equals to 5. So in the given options, this one is gone, this one is gone. A5 common in both. B1 and D3 are also common. So it wouldn't make sense to solve for B and D. Just solve for C again in order to save time and you are done. So what is C? SI square plus 2RR. So these are circumcenter and incenter. So you need to know the distance between circumcenter and incenter. I don't know if you have seen this theorem, but this is equals to square root of R square minus 2RR. Euler's theorem for geometry. Minus 2RR. So plus 2RR would be what? Cancel. This is equals to R square. So option C is 2. So this is the correct option. So we are done with almost, I would say not almost, all of the trigonometry problems that were asked. There were total 9 questions. So thank you everyone for watching the video. If you think I have made some mistake in the video, kindly let me know. I will try to incorporate or make a comment or change it. Okay. Thank you everyone.